Hello, my dear students. So in this video, this is the first of the lecture video series on our discussion of a new chapter in our textbook, which is Work and Energy. Okay, so for this first video, I'll be discussing about, where is that? Work done by a constant force. So I hope by now the concept of force as an interaction is already clear to you, no? So when as you studied the dynamics of motion, or uh, the effect of force on the motion of an object, no, wherein you studied the three laws of motion by Newton. So by in this at this point of our study of physics for engineers, we will be talking about the relationship between force, okay, and then the energy exerted by the object, as the object exerts a force on a certain another body. So yung nag-exert ng force, syempre uh, that object cannot do that without a certain source of energy. So there has to be a source of energy. For example, ako, if I will push something, the energy that enables me to push that is, of course, the energy that I got from the food that I ate, no? When it has uh, been processed chemically para magamit ko yung energy, then I'm able to interact with another object. When I say interaction, it's either a pushing force or a pulling force. And then the things that you learn about forces in the previous chapter, no, the tension, friction, weight, ano pa, normal force, we will still be uh, encountering them because these are the same forces that do work. Okay, so that's the relationship now. As we expand our study of the physics principle, I hope na dahan-dahan yung matuhog, no, yung mga physical quantities na pinag-aaralan natin since day one. Think of it as hindi siya stand alone, because as we go along the semester, the principles that you learned are actually, hopefully makita ninyo na okay, related pala sila. Kaya it's very important na you learn vector addition, you somehow understand kinematics, ano ba ang meaning ng acceleration, velocity, position, displacement, and then ano ba ang meaning na ano ba iba't ibang klaseng forces? Ano ba ang mangyayari sa motion pag merong in-apply pero pag merong natanggap na force? So at this point, all those principles that we've learned, gagamitin pa rin natin in our understanding of the relationship between work and energy. Okay? And then makikita natin along the study natin na there can be no work if there's no force applied. Okay? So, parang ganyan yung takbo ng pag-aaral natin, no? One step at a time. Okay. So let's start with the simplest one. Okay? How do we define work? Okay, by ayan na naman yung aming aso ng aming kapitbahay. Ay, Diyos me. Okay, sige. So let's define work first in its most basic or fundamental definition. Okay, so the concept that we have in our common sense about work is not always the same with the physical meaning of work. So for example, if you are just sitting on your study table, let's say studying something for 2 hours, just reading something, no? A physicist would say that you are not doing any work, no? So the physical meaning of work, zero yung ginagawa mo na work. Pero sa atin, it's a tremendous amount of work because you are using your brain, no, in trying to understand what you are reading. So in other words, our commonsensical meaning of work is not always uh, parallel or the same with the physical meaning of work. So ano ba itong physical na meaning ng work? Okay. So work, as you will notice, as we will know later, it is very much interrelated with energy. Kaya they have the same unit, no? Joule yan siya. So ano ba ito? So let's start with the most simple, the simplest. So let's have case number 1 muna. We are still talking about forces that are not changing in its strength while it is being applied on an object. So constant force siya regardless kung saan na banda yung object habang pinupush or pinupull, hindi nagbabago yung lakas ng pwersa. Okay, constant force. And then another idealization, let's talk about motion along a straight line muna. So it's either the x-axis is horizontal or either pagpaakyat or pababa sa ramp. Hindi muna natin i-include yung curve path. So the simplest would be, let's say, if the force applied is parallel to the displacement. Okay, so let's define some terms here. Alam na natin ano itong F, di ba? It's force. The force that I'm talking about here can be any kind of force. Pwedeng weight, pwedeng friction, normal force, tension, etc. Let's just take it in generic muna. And then you have the parallel symbol. So S here is our generic symbol for displacement. Okay, so displacement. We encounter this physical quantity displacement in kinematics, no? So if you recall, displacement is a change in position. Change in position. So we are now recalling the things that we learned in kinematics. Change in position. So displacement is a vector quantity, okay? And then also position is a vector quantity. So if we focus our attention on a straight line where we only focus on the x-axis, okay? Therefore, we say that x sub 1 is our initial position, okay? In other words, ito yung physical quantity na magsasabi sa'yo kung saan ang particle mo with respect to the origin. And it's a vector quantity. If the particle is at the right of the origin, it should have a positive sign. Kung nasa left siya, it should have a negative sign. Kung nasa origin siya, ang position niya 0. Okay? Please take note of that. So, x sub 2, we take it as the final position. So, ito yung natural, saan siya makikita after ng certain interaction, after nang hinila ba siya or pinush ba siya. So, change in position, the mathematical operator for change is Greek letter delta, if you remember. So, we say here that the change in the position vector is just the final minus the initial. And then for our particular discussion of work, we will use this generic symbol for displacement when it comes to work, no? Para may distinction lang. So tatawagin natin tong change in position as S. Okay? Pag nasa y-axis tayo, the y sub 1 is your initial along the x, and then we also use y sub 2 as the y-axis, I mean. Y sub 2 as the final position along the y-axis, and then we say that the change in the y position is equal to final position in the y-axis minus initial position in the y-axis. And then we can also refer to this as S. So what I'm trying to say is, si vector S, yan yung generic symbol natin for displacement. Okay, nakuha ba? Let's continue. Let's go back to our case number 1. What if the force applied is parallel to the direction of the displacement? Yan. So an example would be, okay, x-axis muna tayo. Let's say, ito yung box natin dito with a certain mass. This is initial point niya. Kaso, pinush siya ngayon ng certain force. Now, so sa initial position, that would be your x sub 1. And then we take this as our, let's say, the reference such that initial position is 0. And then, tinulak siya hanggang makarating siya sa position 2. Ayan ngayon. So, ayan. So, the length of the force here that I am drawing, yung arrow natin, hindi siya humaba, hindi umikli. Kasi nga, constant yung force. Same strength, same direction. Okay? So, the displacement vector now would be from this point to this point. Yan yung displacement niya, x sub 2 minus x sub 1. But we can also just say, for example, ipakita lang natin ng direction ng S, pwede naman ganyan lang natin. and then S here. So we have here, the force is in the same direction with the displacement. Yan. So for this, we say that, balik muna tayo, hindi ko pa pala nabibigay. So the most fundamental definition of work, this is the dot product of the force applied and the displacement. So ayan, I think I've mentioned this in our very first topic on scalar product. So ito na yung pinaka-example natin ng scalar product. So if you recall, this is scalar product. Every time makita niyo yung dot, or tawag natin sa kanya, dot product. Ayan. So the dot will remind you that it's really a dot there. And then the scalar term here will remind you that yung resulting quantity dito from the two vectors here, ito vectors ito, di ba? But their dot product is a scalar quantity. So meaning to say, work has no direction. Okay, so it's a scalar quantity. Meaning, kumpleto na ang identity niya by giving its magnitude. So, walang sense kung magbibigay ka ng direction kasi wala siyang direction. Yan yung scalar quantity natin. Okay? Pero yung parents niya, vectors. Ayan. So, further recalling sa dot product, if you recall sa dot product, we have any vector, tapos i-dot mo siya sa another vector, then you have, it's equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. If you recall that product. Yan. So what we do, we connect these two vectors tail to tail, di ba? So say for example, if vector A is going here, and then vector B is going here, make sure that you do not get confused with the angle. So si phi dito, ang definition niya is the angle between the two tails of A and B. So, hindi lahat ng angle na ibibigay sa problem, yun kaagad ang isa-substitute, ha? Si phi dito, i-sketch nyo muna kahit sa scratch lang, i-tail to tail nyo yung dalawa, and then the angle between them, that's your phi. Ayan, stop na naman siya. Ano naman yun? So, this is angle phi. So, I hope you now appreciate that product no, that we learned in the past. Meron pala siyang kabuluhan dito. Ayan. And then, so therefore, we can say therefore that if we will let force be A and S be B, so si work pala is just the magnitude of F times the magnitude of the displacement, which is just the distance between 2 points, and then the cosine of the angle between them. Yan. So that if the force dito, balik tayo dito, if the two vectors are parallel with each other, anong angle between them? If they are going in the same direction, natural, so if two vectors are going in the same direction, edi walang zero ang angle between them. Let's say A is going here, B is going here. So pag i-tail to tail mo yan, ang phi nila is 0. And then remember, cosine of 0 is positive 1. So for the simplest case natin dito, in other words, if the force pala, kung obvious na kaayo sa sitwasyon class, nga ang applied force in the same direction or parallel with the displacement, edi, automatic na. The cosine 90 here, cosine 0 here becomes positive 1. Ito, magiging positive 1 ito. Kaya, for this special case, I mean a very simple case, the work done by the force F here, so may subscript ka ng, I am suggesting na pag solve na kayo ng work, lagyan nyo ng subscript kung anong force ba ang gumagawa ng work na yan. Kasi in a system, there are several forces acting. For example, itong si box, meron siyang weight, merong normal force. So, pwede pang ipasolve sa inyo ang work na yan. Kaya lalagyan nyo ng maliit na letter dito, subscript lang, ha? Ayaw dakua. So this becomes immediately, ano ba yung magnitude ng force? Ano ba yung distansya between the 2 points here? Then immediately, this is now the work. And it is positive, no? Kasi positive 1 yan. So, meaning to say, from this definition of work pala, nakalimutan ko ibigay ang unit. So, the unit, the SI, International System Unit, specifically the meter, kilogram, second, ang unit niya would be Newton meter, which is identical to joule. It's not joule, it's joule. Ha? Ano na siya pagbasa? Joule. Joule in the palace. Capital J. So, which is also the same unit with the energy. Kasi work class is somehow energy from a certain body, either iyahan ng ibalhin dito para makalihok, or pwedeng energy that is removed from the system para maghinay-hinay siya glihok kasi mabawasan siya. So work and energy are that very much related, no? Kaya pareho sila ng unit. Learn pa natin yan later. Aside from joule, another units would be calorie. Okay, sorry. We also have lagyan natin to ng 1. 1 Newton meter is equal to 1 joule. Ayan. So, what else? We also have calorie. Sila gani ang isa ka calorie? Tama pa niya kung kuan. Wait. 1 calorie is 4.186 joules. Yeah, tama. Sige. So, unit natin. Pag merong work na naka-calorie, dapat i-convert ka agad to joule. So, 1 calorie is 4.186 joules or 4.19 joules. And then, we can also have, of course, 1 kilocalorie is just 1,000 calories, of course. Or 1 dietary calorie. Nakakapitalize yan. Ito yung mababasa nyo na calorie label sa mga food packaging, the dietary calorie. So if a chocolate bar says it's 3 calories, it's actually containing 3,000 real calories. No? Ayan. Sige. So let's continue here. So that's the simplest case. No? Now, let's talk more about the meaning of this positive work. Ito. Ano bang physical meaning ng positive work? Kasi if you recall, si dot product, although wala siyang direction, but because of the angle between the two vectors, the dot product of any two vectors can be positive, it can be negative, or it can be zero, depending on the orientation of the two vectors with respect to each other. So, ano ngayon ang physical meaning ng mga signs na ito? Kasi nga, hindi ito direction, ha? Not a direction. But it has a different physical meaning depending on these two vectors. So, in this particular case, we have force and displacement. So, si positive work class, if you notice here, si positive work happens if your system, in this case, our system is the box, no? So, system is box. Yan. So, if the system receives the energy, then that force will be doing a positive work. Kasi parang siya yung nagbigay, no? So, in other words, pag nakatanggap ng energy ang system, yung work ngayon na ginawa ng nagbigay is positive. Okay? Kasi, nakatanggap ng energy yung box dito and that energy enabled it to change position. Kaya kung wala yung energy, di na siya kalihok. Tama ba? Ayan. So, meaning, if the work done by a force were positive, okay, greater than 0, positive siya, the system receives energy. Receives energy. Ayan. Okay? Or another way of saying would be, work is done on the system, not by the system. The system. Ayan. So I hope you are focusing on the concepts here, no? Kasi mas madaling mag-solve ng numerical problems kung naintindihan nyo yung konsepto. Ayan. So that's the simplest. Now, i-opposite naman natin. What if this time, let's have case number 2. So for case number 2, what if the force this time is at a certain angle, no? Force at a certain, wag na lang yan. Okay, obvious naman yun na, it's a certain angle, no? Kasi sa case 1, phi is 0. The angle between them is 0. What if the force this time is, special case number 2, perpendicular to the displacement? Okay? Perpendicular to the displacement. So let's go back to our figure in the first example. Pero mag-focus tayo sa perpendicular forces. So we have, ito yung box natin kanina. Ito naman yung position 2 niya. So ito yung F. In the case 1, na-solve na natin ano yung force niya. Now say for example, ano pa bang ibang forces na natatanggap ng box dito? Meron siyang support sa ilalim. Ayan. Naa siya'y salog sa ilalim. So meaning the bottom of the box here is being pushed up by the normal force due to the floor. It's 90 degrees with that. Ang displacement ng box papuntang right. So, ano ngayon ang angle between the normal force and the S? Diba 90? So, in this case, the phi is 90. O, ano ba ang cosine ng 90 according to your trigonometry? Diba it's 0? So, in this case, if we still go back to the definition of work by constant force, Fs cosines phi, ito siya magiging cosine 90, which is of course magiging 0. So, walang work na nagagawa ang perpendicular force. That's the bottom line. So, pag obvious na sa problem, ng applied force is 90 degrees, ay, nanyo i-solve. Klaro naman sa TB-TB nga walay ginabuhat. Kasi, yung ginagawa ng normal force dito, kina-counteract niya lang yung bigat ng box. Wala siyang contribution para makalihok siya to the right. No? So, wala siya work. So, the work done here, subscript normal force is 0. What are the other forces here? Of course, meron siyang mass. Ang box merong mass. Mag-i-interact yan sa mass ng Earth. So, meron siyang gravitational force na natatanggap, which is just equal to its weight. So, this is F gravitational, equal to its weight. Ganun pa rin. Habang pinupush yung box to the right, displacement is to the right. So, the angle between F gravitational and S is also 90. So, the work done by gravity is also 0. No energy contribution kasi 90 degrees siya. Okay? Yan. Now, let's go to the third case. I'm almost done with this first video. And then we have third case. Let's say, what if F is in the opposite direction, anti-parallel with the direction of motion? Okay? So, ano kayang anti-parallel na force dito na natatanggap yung box? If you notice, let's say, merong certain coefficient of kinetic friction yung box, hindi 0. It's the coefficient of kinetic friction between the box and the floor is not 0. So, habang pinupush ito to the right, then friction will also be acting on the box. Parang nakasandwich siya sa dalawang surfaces. I'm sorry. So, as the motion is to the right, friction is kontrabida. So, dari na siya. Yeah, kaya nag-slide naman niya sa floor, this is already kinetic friction, hindi na static. Walang nagagawang work si static friction, ha? Kasi ayaw niyang gumalaw yung object. So, it's always kinetic friction that is involved here. So, let's sketch now tail to tail the two vectors. We have displacement. Ito pa rin as sitwasyon. Going to the right, yung change in position. Pero yung friction natin is in the opposite direction, kinetic. So what is now the angle between them if they make a straight line? Yes, angle phi is 180 degrees. Very good kayo. And then what is the cosine of 180? So if we go back, the work by the friction now is you have kinetic friction times S. Tapos you have your cosine 180. Cosine of 180, this is negative 1. So it means pag anti-parallel pala yung force, you just multiply the applied force, in this case, it's friction, times the distance, and then lalagyan mo na lang kaagad ng negative. Pwede ka nang hindi mag-cosine 180. Ito na yung shortcut natin for anti-parallel. Okay? So, we mean here that for friction, since it's always opposing the direction of motion, si friction, ang work niya always negative yun. No? Because of the rubbing of the bottom of the box and the floor, the energy, this tawag nito, itong area of contact dito, habang nagra-rub yan, this will heat up because of the rubbing. So the heating up, this is already at energy transformation. It becomes thermal energy. Okay, because of the rubbing, no? Because of friction. Ayan. So sooner or later, kung bibitawan na kung mawawala na itong si pushing force natin na F, oh my God, wait. Da, da. Nak, ihatag ang phone please. Nag-record ko. Sorry, number lang. Sorry for that. I cannot repeat the video. Bahala mo diha. Okay. Ayan. So, asa na tayo? So, in other words, what we're saying here is, if the work is done by a force is negative, no? If it's less than 0, then we say that the system now is losing energy. So, nawawalan siya ngayon ng energy. Kaya sooner or later, pag nawala na itong pushing force, itong box na ito hihinto. Kasi yung energy niya, because of its motion, will be converted to thermal energy. Yan. And then this becomes warmer than the environment. Now, the energy will always go from a higher temperature to a low temperature. So, mangyayari, lilipat yung energy sa environment. And itong energy that is transferred to the environment is forever na. Hindi na yan pwedeng you cannot catch it and then put it back to the box, no? It's lost na ngayon. Kaya meron talagang energy loss. Energy loss. Ito energy dito. Energy is lost. Energy is lost. Ayan. So that's what we mean by negative work. Meaning system loses energy. Yan. Or another perspective would be it's actually the system that does work. So we say here, opposite ito ng parallel kanina. So we say that this work is done by the system. And this is happening because of its interaction with the floor, no? Because of friction. Ayan. So these are the three simple cases. The other generic one would be, let's say, F at any angle with S. So this can be any, ano na, let's say for example, tension, diba? So say for example, this is the box, and then you tied it to a rope, and then you pull it. Yan. So, yung force mo actually, yun yung natatransmit sa lubid and it acts now as tension. Kasi nga, the rope naman cannot pull the box by itself, di ba? So, the applied force now is tension. Okay, let's say this is at a certain angle. And then let's say the box here, you're able to pull it until andito na yung box. Ayan. So, this is initial position, this is final position. So, ang direction of motion natin, ang displacement is going to the right. So pag i-connect mo ngayon si tension, tail to tail with displacement, this is just the same with this angle, whatever this angle is. So this will now become angle phi. Yan. And then the work done by the tension, therefore, it's just the force, which is tension, times the distance, times the cosine of whatever angle there is. Yan. Okay? So in this case, the work done by the tension here will be less compared kung hinila niya lahat ito na pag ganyan yung tension niya. Kasi pag horizontal yung tension, the angle between them will be 0. So the work done by tension in that case is just tension times S. Pero dito, pag nilagyan mo na ng certain angle, less na yung work na magagawa ng pulling force mo, even if you did not change the magnitude. So let's say this is 50 newtons. This is also 50 newtons. I'm sorry. Ito pala, 50 newtons. Yan, no? So, ito 50 newtons din. Pero hindi na lahat ng 50 newtons ang gagawa ng work. The only component of T that does work here is the Tx lang. So, if we show the component, this is now Tx and this is now T sub y. Tama ba? So, si T sub y is 90 degrees with S. So, walang work na nagagawa si T sub y. It's 0. The work done by T sub x is Tx times S. Kung i-separate mo siya ha, this is now looking at it as a parallel component. So, the Tx, this is solved by T, and then you have cosine of phi, tapos meron kang S. So, ang work Tx is Ts cos phi, which is just equal to the total work of the tension. In other words, class, you can look at it at different perspectives. Perspective number 1 is this. So you have the work is equal to F S cosine phi. Yan. Itong force dito as is siya. Okay? Pero, we can also say that the work is, you look for the parallel component of force and then you multiply it with S. Huwag mo nang lagyan ng cosine phi. Kasi sa perspective na ito, hahanapin mo yung, pakisaksak ng charger please. Hahanapin mo yung parallel component, just like what we did here. No? So, sa first perspective, ito yung ginawa natin na tiningnan natin to, this is tension, T, and then this is S. So, nagdiretso tayo sa Ts cosine phi. Pero, sa perspective 2, we resolve the components of T, and then wag na nating pansinin itong perpendicular component kasi alam naman natin na walang work yan. Mag-focus ka ngayon sa parallel component. And obviously, it's Tx that is parallel to S. Kaya dumiretso ka, Txs. Pero bumalik ka pa rin dyan sa definition na yan. So, ayan siya. And these are all equivalent to F dot S. So, meaning to say, pag si force naman, I'm almost done. If the given force class is given in unit vectors, let's say meron kang force na 3D. Let's say you have 5i plus 3j hat plus 2k hat. Yan. So, 3D na force yan kasi nasa 3D space. And let's say the change in position, the displacement is given by, let's say, 2i minus let's say j, let's say plus 3k. Yan. And then sasabihin, what is the work done by force F? Eh di ito ang gagamitin mo. Diba? So if you recall, this will be, pag naka-component siya, if you recall, so this is Fx, and then you have the x component, plus Fy, the y component of position, plus Fz, and then the z component of the position. Kasi if you recall, a dot b is equal to, pag naka-component siya, ax bx, remember this? Ay by plus az bz with the corresponding signs. Yan. Yan. So, the work here by friction will be, puput together natin yung dalawang x. So, 5 times 2, and then you have I dot I plus, ito na ulit, 3 for this one, for the y, 3 times negative 1, and then you have j dot j, and then you have 2 times 3 k dot k. So, that product, wala na ito, mawawala na ang unit vectors kasi walang direction, di ba? So, I dot I, this is equal to positive 1, this is also 1, and this is also 1. And then we have, so 5 times 2, this becomes 10 minus 3 plus 6. Therefore, the work done by force F here is 713. Tama ba? 13, and it's positive 13 joules. Okay? So, ganyan siya. Kung naka-unit vector, edi itong equivalent ng dot product ang gamitin nyo. Pag binigyan kayo ng magnitude ng F at saka ni S, edi ito ang gawin ninyo or either ito. So, once again, these are for constant force, tapos straight line. Yan. Okay, and then finally, patiwasan na lang yung class ha, para lahi na puntong pan. And then finally, we say for a constant force, let's say we now have, ito na naman yung graph natin. So we now have here the force versus position graph. I asked you sa graphing na dapat merong title ang graph. Anong next dito? Lalagyan natin ng label ang x-axis. So dito ngayon si position, siya ang independent variable. And then unit lang muna ang, variable unit lang muna. Hindi ko lalagyan kung meter or centimeter, whatever. And then this one here is your force. So kung i-graph ko ngayon, yung graph ng applied force ko, so say for example, yung ginamit natin na F kanina, if F here is let's say 30 newtons, and then ito yung position 1, and then later nakarating na dito si box natin, and then let's say that the distance here is let's say 3 meters. So pag i-graph natin ngayon ang force versus position ng force na ito, so lalagay ko dito meter, lalagay ko dito newton. Yan. So the force here, applied force, does not depend on position. Okay? Force does not depend on position. Meaning, kahit saan pa dito yung box, let's say nakarating siya dito ngayon, yung force 30 newtons pa rin. Pagdating ni 30 newtons hanggang na-travel na yung 3 meters. Eh di ang graph natin ngayon, pwede kang maglagay dyan ngayon ng 30 newtons. And then this is 0. And then this is a 1 meter, 2, and 3. So the graph now, constant graph. Ayan. So, if we get the area under this curve, in this case, it's very obvious that the graph is a rectangular plane. So, if we get the area of the F, this is X along the X. Yan. Fx, X graph, it will give you the work done. Work done from x sub 1 to x sub 2. So, depende na ngayon sa iyo kung asa si x1, asa si x2. So, in this case, since it's just a rectangle, the force is positive, position is positive. So, the area of the rectangle is just length times width. So this is now equal to, the length is force x, and then the width is change in position. So therefore, this is now equivalent to the work done from this one. So for this particular case, the work is just, so let's say, what is the work done from 0 to 2 meters? Oh, kunyari ganyan. 0 to 2. So ang length would still be 30 newtons. Yan. I mean, the height here is 30 newtons. But, pag 0 to 2, edi ito lang. Ito lang na portion. Ito, hanggang dito lang. So, this would also be 2. So, it's positive 60. Pero kung ang question is, what's the work done from 0 to 3? Edi, it's 30 times 3. So, we have 90 joules positive. Okay? So, yan lang naman. So, pag titignan, ibig sabihin, pag binigyan ka ngayon ng force versus position na graph along the x, say for example, the graph looks like this. Let's say changing na, nag-increase, tapos nag-constant, tapos nag-decrease, tapos nag-constant ulit. Yan. So, tapos ito, pwede itong different positions na yan. And then, tatanungin ka, what's the work done by F from this to that? So, let's say this is 0, 2, 4, 6, 8, 10. And let's say this is in meter. This has to be in Newton para naka-joule siya. So, from 0 to 2, you have here a triangle. And then, positive F, positive X. So, the work done from 0 to 2 would be 1/2. Lagyan natin ng value. Let's say 10. 1/2 times the base is 2 and the height is 10. So you have here positive 10 joules. Tama? Pero pag sinabing, what's the work from, let's say, 8 meters to 10 meters. Okay, so ito na siya. Inverted triangle ulit. So, let's say this is 5, negative 5. So, nasa fourth quadrant na ngayon si force natin. Nasa negative force na yan. Opposite siya, no? Sa direction. So, since this is just a triangle, then we have, it's still 1/2 times the base is, from here to here, it's 2. And then the height would be negative 5. So, this is negative 5 joules, something like that. Okay? Pag ang question is, what's the total work from 0 to 10, edi i-add mo. Ano yung work here with, algebraically yan ha, ano yung area nito, itong square na ito, and then kunin mo din ito, and then hanggang dito. And then i-add mo lahat algebraically. That would be the total work. Okay? So, let's synthesize. Medyo mahaba ang lecture ko sa video na ito. At this point, we're able to define work by a constant force. No? So we have F dot S equals Fs cosine phi. We also say that it's equivalent to F parallel times S. Or we have F Fx, x position, F y position. Kung mag 3D ka, F, Z, Z position. Ayan. And then we also say that the work done by a force is equal to the area under the force position graph. Ayan. That's it. Okay. I rest my case. In the next videos, I will be discussing several examples. I'll be talking about work done by a varying force. So please mag-practice kayo mag-solve ng mga problems on constant force muna. Okay? Ayan. Until then, bye-bye.